I have minus 3q squared divided by b to the 5th to the 4th power. Again, I just distribute. This is minus 3 to the 4th power, q squared to the 4th power, divided by b to the 5th to the 4th power. Negative 3 to the 4th power is negative 3 times negative 3, which is 9. And then negative 3 times negative 3 is 9. So I multiply those together. 9 times 9 is 81. This is multiplication. I get to the 8th power divided by b to the 20th. And that's really it. They're not as hard as they look. They're way more scary looking. Don't let your mind tell you that these are really hard. Just use the rules I gave you. What do? The first thing I would always do personally, and it doesn't matter, you don't have to do what I'm doing, but I like simplifying first. I could multiply everything to the 4th power, just like I did in the previous, but I can make this a little easier on myself if I simplify what's inside the parentheses first. 9 over 6, I can divide both of those by 3, and I get 3 over 2. I have x to the 3rd on the top and x to the 4th on the bottom. Well, I know I have to subtract. The easiest way to use that rule is if the bigger number is in the numerator, then subtract 4 minus 3. If it was backwards, if it was x to the 4th over x to the 3rd, I would subtract and I would get x to the 1st power. But here it's in the denominator. Again, the easiest way to do it is to subtract the bigger number minus the smaller number. But then, since it's bigger on the bottom, I'll have that x on the bottom.
Right.
Did that make sense?
Yes.
Perfect. Same thing here, z to the 6 minus 5. Well, I have 1 extra z in the denominator. I'm just going to shorten that a little. And now I have simplified what's inside the parentheses. So now I don't have all that stuff going on. Everything didn't get just bigger and bigger. It got smaller. Now this is easier. 3 to the 4th divided by 2 to the 4th, x to the 4th, z to the 4th. 3 to the 4th, we already said, is 81. 2 to the 4th is 16. X to the 4th, z to the 4th. So just go like methodically through it. Don't get nervous, and it'll come out pretty simply. Didn't that come out pretty simple?
Yes, it did.
Okay. And it was frightening to begin with, right?
Yes.
Okay. But look, it was just like step by step. What I find is that people who worry about what is the answer have a hard time. Just look to see what's the next thing you can do to make this easy. Okay. Then what's the next thing you can do? Then what's the next thing? Don't worry about what happened prior, because we've made it easier, right? And we're going to keep doing that until we're done.
Okay.
Don't count your steps. You know, people sometimes get scared. Oh my gosh, there's so many steps. You wouldn't have to worry about how many steps you have unless you are memorizing. Because if you're just going from step to step, who cares, right?
Yes.
Now we know also that any value to the 0 power is equal to what? 1.
1.
Okay.
So that first answer is 1.
Yes. Now we have this. Now we're going to use 2 different rules that I taught you today. One rule says that the exponent only affects what it's next to. What is the exponent of 0 next to?
The 7.
Nope.
The 7, negative 7/3.
The parentheses.
The parentheses. Oh, the parentheses. Okay, okay.
It's next to the parentheses, which means that everything in the parentheses is going to be 1. This part right here, all of this
It's just 1.
is just 1. This becomes -7 times 1, which equals -7, period. That's it. The exponent only affects whatever it's next to. Here it's next to the parentheses. It doesn't even matter if inside the parentheses I have all this. If that was to the 0 power, it would equal 1 because it's next to the parentheses. Oh, we know how to do this. We went through all this, didn't we? Now, 5 to the -4th is really the same as 5 to the -4th over 1. This is already on the top. I put it on the bottom and it becomes positive. Well, we never see a fraction with nothing in the numerator. We just put a 1. Actually, this would be 1 over 25 times 25 because 5 squared times 5 squared is 5 to the 4th. 25 times 25 is 625.
And that will be your answer.
That would be my answer. 8 over 3 to the -2 power.
And as you said, the -2 is only close to the parentheses.
Right. So there's 2 ways we can do this. Okay. I'll show you both ways. One of them is I can say this is 8 to the -2 divided by 3 to the -2, which would be the same as, well, 8 to the -2, that's going to go where?
At the bottom, because it's already at the top.
Exactly. How about 3 to the -2?
That goes at the top.
And becomes 3 squared. So
Yes.
this becomes 9 over 64. One way. The other way we can do it is we can literally say that 8/3, this is a little trick. I don't know if it's trickier, but it's a little different. So I can say this is 3/8. All I did is flip the fraction squared. Because I take the negative, really what we're doing is always flipping them, right? When they're negative. So I can do it this way, which is still 9 over 64. If you had this problem, let's see how you would do this.
Okay.
There's multiple ways, so don't get scared.
Okay. What I will do, I will put the 5 over 2 at the bottom of the line. Oh, you didn't draw the line.
Okay, let's draw the line first. Because the negative does not disappear. The only thing that disappears is the negative in the exponent. This would be -5 squared. Because this is the same as 1 over -5 times -5, which is 25. How about this? Without skipping a step, because I did skip a step there. That's true. It affects what it's next to. It's next to the parentheses. So I have 2 of them. And then we have -5 times -5 is positive 25. But we can do this more than one way. What's one way that you can think of that I can do it?
Okay. Because I was actually thinking about it right here. And hold on a second. Okay. So it's a to the -1 multiplied by a to the -9.
Okay. So what is the rule that you're going to use? Did you write down all the rules?
I did write down all the rules.
Why don't you look at the rules and see which one you would use? I have a base to a power times a base to a power, right?
Uh-huh.
So I add. -1 -9 is -10, isn't it?
Oh, because the base are the same while you multiply.
Yes.
Oh,
So
okay.
same rule, nothing different. Now I have this negative exponent. So what do?
You make it positive
How?
by okay, so we put the A,
We put our
we go
fraction line, don't we?
right, and you put the A minus 10 at the bottom to make it positive,
Yes. And then you
and
just
then
put
put a 1.
it. Or I could do it by saying I have a to the -1, because this is on the numerator, so that's got to go to the denominator. Same here. Has to be something in the numerator. Now I have a to the first, a to the ninth. I add because that's the rule. This becomes a to the 10th. Either way, same answer. I have -2 v to the -4. Tell me how to rewrite this.
Okay. Draw the line. The -4 is close to the V.
Yes. Let's look at each piece separately. Let's say I have -1 times 2 times v to the -4, because that's really what I have. Because if I put an exponent up here, I'm just doing 2 times 2 times 2. I'm not doing the negative. They're really separate pieces. It really looks like this. You don't have to do it like this, but this is, again, strictly for teaching purposes. I would say, I'll put my fraction line. Well, -1 is to the first power. 2 is to the first power. And v is to the -4th power. They're all separate pieces. This is equal to -2 divided by v to the 4th. What's the first thing I'm going to do?
The fraction line.
2 times 6 times 2, 6, 5. I personally recommend that you cross them out as you go, because we're going to go all over the place and we're going to forget where we are. We have s to the -7th. Where does that go?
At the bottom.
As a positive, right?
Right.
Boom. T to the -6th.
That goes at the bottom.
As a positive. Boom.
And then V go at the bottom as well.
Yep.
And then so the -9 goes at the bottom.
Perfect. See why it's good to cross things out?
Right. And then the S to the -2 goes at the bottom.
Yep.
And then the V to the -8 goes at the bottom.
We're already halfway there.
Right. And then we multiply 2 by 6 by 5.
And you know what? It might even be easier to multiply. 6 times 5 is
30.
Times 2.
60.
60. Isn't that easier than 12 times 5? For most people it is. If it's not for you, then it doesn't matter. But like, you could, if you have a bunch of numbers to multiply, you could even do 2 times 5, because that's really easy as 10. And then 10 times 6 is 60. Right? You can do them out of order as long as it's multiplication, and that might help. Let's collect our things at the bottom.
So now you have S7, S2.
You see it? It's right here.
Oh, I didn't see that one.
You would later. What I mean by that is, if you cross out stuff, then all of a sudden you'd be left with this thing. It's like, oh, I guess I didn't collect that one. Well, I only have one t.
Right, so it's t to the 6th power.
And then how many v's do I have?
13.
Perfect. Okay. Am I done?
No.
Oh, good. I'm not done. What do I have to do now? I'm only allowed to have one of each variable. This is the same as 60 over s to the 18th, v to the 13th, times t over t to the 6th. I separate it because it makes it easier because the bases have to be the same. If I have b to a power divided by b to a different power, I subtract. This is going to be 1 minus 6 is negative 5. I don't think that's the easiest way to think about it because then I have a negative exponent. But if I know that 6 minus 1 is 5, and I know that I have more in the denominator than the numerator, can't I say this? Well, I have how many? I'm going to have 5 t's in the denominator, aren't I? This is really times 1 over t to the 5th. If I put them back together and take away this 1, there's nothing to combine the t's with. I tag it on the end.